Okay, so here we want to review the increasing, decreasing, and constant of a function. So what we are trying to identify here is we are trying to identify the open intervals. The open intervals, meaning you're only going to use parentheses, right? Open intervals of x where the function, which means y values, are increasing, decreasing, or remaining constant. Okay? So the way that you identify whether or not they're increasing, decreasing, or constant is by the flow of the graph. So if the y values are increasing, it's going to be like you're going up an escalator. If the y values are decreasing, it's going to be like the graph is going down, like you're going down an escalator. And if they're constant, it's like you're just going straight on like a tram, right? So that just means constant. The y values are not changing. So what we want to do, because we are identifying the open intervals of x, we are identifying the x values when we are doing this, because we want to identify what are the x values that the y values are increasing, decreasing, or remaining constant. And so increase, decrease, or constant. We don't know what we're going to get, but we know what our options are. And so then we just follow the function. So as we begin, we read the graph from left to right. Why? Because we are identifying x values. And x values, the left to right is how the number line runs. So as we move in, we see that we start here at an arrow, which automatically signifies from negative infinity. So as we follow the graph, as you see, we are doing what? We are going down. So the y values are decreasing. Well, what is the interval in which they are decreasing? They are decreasing from where the x is negative infinity all the way until the x is at -3. Okay? Then we follow the graph again. As we continue the flow of the graph, we see now, oh, the y values are increasing here. So where, on what x values are the y's increasing? Well, the y's are increasing from -3 to, do not use the 4. The 4 is a y value. You have to make sure you look at the x. From -3 to -1 is where the y values are increasing. Okay, then as we continue on, we see that now the y's are decreasing again, and the interval on which they are decreasing is from -1 to +infinity. And that would be it. This graph, or the y values, this function is never remaining constant. And that's increase, decrease, constant. Within this exact same problem, we can also identify the max, the relative max, and the relative min of a function. So the relative max signifies the point where the graph or the function changes from an increase to a decrease. So it creates a max when the graph changes from an increase to a decrease. The relative min is when the graph changes from a decrease to an increase. So it creates a relative min when the graph changes from a decrease to an increase. So it creates a valley. The max creates a hill. The min creates a valley. So when we look at this particular function in this graph, And if we wanted to identify the relative max and min, what is going to happen is we are going to be asked at which value is there a relative min and a relative max. That value is representing the x. Okay? So at which value is there a relative min? Well, the relative min is going to be this point here. The relative minimum is going to be this point right here. So a relative min is at -3, 0. But the way the question is going to be phrased, at which value is there a relative min? There is a relative min located at the x equal to -3. What is the relative min? 0, because the relative min is always going to represent the actual y, the output. So at which value is there a relative maximum here? So here, this would be considered a max, a relative max here. So you see, it creates this hill. And so what is that ordered pair? That ordered pair is -1, 4. So as I answer the question, at which value is there a relative maximum? There's a relative max at x equal to -1. What is the relative max? The relative max is 4. Okay? And that's that.